Okay, so our second installment in our interesting radicals problems are examples that look like this. So this one you have 21 plus 12 root 3 to solve it. So you got it what we refer to as a nested radical. And so on a nested radical, what we're going to do is similar to what we did when we had the sum of two different nested radicals, we're going to set it equal. Now, before we set it equal to x, which is great. So when we square both sides of this, that's going to give us 21 plus 12 root 3 equals x squared. Well, that really didn't get anywhere because the left side is just like it was before. And so if we try to take the square root of both sides, then it doesn't work. So instead, this one's a little bit more subtle in how you do it. And it involves some guessing and checking. And so the guessing and checking we do is we say, we think there is an easier, simpler version of this particular problem. And we think it's going to have the form a plus b radical 3. That's a little bit of a guess and check. And it's always going to be some value a plus some value b times a radical that's inside here. Now, if there were two radicals inside there, then maybe you'd have two radicals, and we might do a problem like that later. Okay, so when I squared both sides, I have to square this whole thing. Well, like before, that's going to give us a squared plus 2ab root 3, right? The product of the two middle terms, or the two terms, times 2, and then plus 3b squared. Now, here's our second part where we're going to use some guess and check techniques, is when we set these two things equal to each other, the non-radical 3 term have to be equal to each other. So we know that 21 has to equal a squared plus 3b squared. 21 has to equal a squared plus 3b squared. And then we also know that 12 radical 3 has to equal 2ab radical 3. Which means that if you cancel the 2 out here, a times b have to equal 6. And that's where how we do this guess and check usually is that part of the problem allows us to come up with good values for a and b that we can then try to make this one work. So if we think about it, a times b could either be 1 times 6, 2 times 3, 3 times 2, 6 times 1. So there's not too many things that we can plug over here and get an answer. And then we also know that it can't be 1 times 6 or 6 times 1 because 6 squared is 36, which would ultimately be too big. So now we try these two. If I try 2 and 3, that would give me 2 squared plus 3 times 3 squared. Well, that equals 4 plus 27, which is 31, which is too big. So instead, I'm going to try this one, which is, does 21 equal 3 squared plus 3 times 2 squared? Well, yeah, this just turns out to be 9 plus 3 times 4, which is 12. That does equal 21. And so that means a must equal 3 and b must equal 2. And so what we've discovered is that the square root of 21 plus 12 root 3 must equal, take the a and the b we found, a is 3, b is 2, put it back here into the original, and you get 3 plus 2 root 3. And these two are equivalent radicals. And so we took this complicated nested radical and we came up with a much simpler radical, 3 plus 2 root 3. We can verify that we're correct by looking at Desmos. If we type in 21, the square root of 21 plus 12 root 3, we get 6.46101615. And so if we then take a look at 3 plus 2 times radical 3, which is what the answer we got was, we get the exact same thing. And so those two are equivalent to each other. Okay, to do another example so you can kind of get an idea on this, if we have the square root of 33 minus 20 radical 2, and we are going to set that equal to, well, we need it to be equal to a plus b root 2. You can decide how you want to handle the negative here. You can either do a plus b root 2 and handle the negative at the end, or you can do it like I'm going to do, which is put the negative at the beginning and say we're going to have a minus b root 2, and then that means A and B will probably end up being positive as we go through here. It doesn't matter where you put the negative and where you deal with your negative sign at. And so if we square both sides like we did on the first problem, that gives me 33 minus 20 radical 2 equals a squared minus 2ab radical 2 plus 2b squared. So that means 33 must equal the non-radical 2 parts, and so that's these two. And then negative 20 radical 2 must equal negative 2ab root 2. And so we cancel out the negative 2's, and so we get AB must equal 10. And so like we did in the last problem, AB has to equal 1 times 10, or 2 times 5, or 5 times 2, or 10 times 1. Again, we can cancel out, rule out the 10s, and actually pretty quickly we can realize that it must be this one, because if we have the 5 as the b, then we get 50 for that second term. And so does 33 equal 5 squared plus 2 times 2 squared? Yes, that does turn out to work out, because you get 25 plus 8 equals 33. So the correct answer to this problem is when A is 5 and B is 2. So that means the square root of 33 minus 20 radical 2 is equivalent to 5 minus 2 root 2. You can go through and type that into your calculator to check out to see if you got the same answer. But if you do, you'd get those two things, this and this, are equivalent to each other.